On this shine afternoon, we like to present our case study which is about a man. First of all, we like to thank Madam Siti Nur Shafinas for giving us this wonderful opportunity. So, before we begin, I would like to introduce myself first. My name is Hemasri Jotan Chandararam and my metric number is 01DDT20F2001. And let's get started. So, the bottom line is it has given the instruction as a tourist wished to have a visit to each city as he landed to the country with minimal distance travel. So, we as a team has decided to suggest the best route for him to enjoy his trip. As we state above, we chose Welcome to Bangkok map. So first and foremost, I would like to express in my word about introduction of minimal spanning tree. Before we learn about spanning trees, we need to understand that it has two graphs, which is undirected graphs and connected graphs. So the first is an undirected graph is a graph in which the edges do not point in any direction. For example, the edges are bidirectional. The next one is a connected graph is a graph in which there is always a path from a vertex to any other vertex. So that is it for understanding about the two graphs. MST, which stands for minimum spanning tree or minimum weight spanning tree, is a subset of the edges of a connected and edge-weighted undirected graph that connects all the vertices together without any circles and with the minimum possible total edge weight. That is, it is a spanning tree whose sum of edges weight is as small as possible. In addition, a tree has one path joins and any two vertices. A spanning tree of a graph is a tree that contains all the original graph vertices. The second point is reaches out to spans all the vertices. The third one is acyclic. In other words, the graph doesn't have any nodes which loops back to itself. So that's it from me. Now I would like to pass it to my next presenter to continue with the next one. Thank you.
Good afternoon to everyone. First and foremost, I would like to take this opportunity to introduce myself. My name is Kruskal Algorithm and my metric number is 01DDT20F2051. On this bright afternoon, I like to continue presenting the technique applied for find minimum spanning tree for this case study. Before to that, there were two methods for forming a minimum spanning tree. Kruskal algorithm will be the first one, while Kruskal algorithm will be the second one. We have choose Welcome to Bangkok map as my previous presenter mentioned. For the Welcome to Bangkok map, we have used the Kruskal algorithm to determine the minimum spanning tree. Kruskal algorithm for finding minimum spanning tree has a few steps. So let me explain about it. The step 1 will be find the edge in the graph with smallest weight. If there is more than one, pick one at random and mark it with any given color. The second step will be find the next edge in graph with smallest weight that doesn't close a cycle. Color the edge and the next incident vertex. Check if including this edge is spanning tree will form a cycle is yes. Then ignore it. If no, then add it to spanning tree. Step 3 will be repeat the step 2 till spanning tree as vertices. So that's how the Kruskal algorithm for achieving minimum spanning tree works. This is my understanding of the technique used to answer this case study question, and that's all I have to say about it, and this is from my side explanation about the techniques. I hope you guys understand based on what I have explained it. Thank you so much for spending the time to listen. Next, I would like to pass the presentation over to Thinagaran Raja, my next presenter.
Thank you, Komli. Hi everyone, my name is Thinagaran son of Raja. My metric number is 01DDT20F2032. Today I am going to explain the solution of minimal spanning tree, include the diagram tree obtained and calculation. Let's do it.
There are a lot of maps in case study. We choose the Bangkok City maps. These are the original maps of Bangkok City. The first edge is Siam Square to Payathai. Siam Square because Siam Square to Payathai is the shortest wait, which 0.5 km among other places. The second edge is Democracy Monument to Chitiada Palace. The wait is 0.9 km. The third edge is Democracy Monument to National Assembly Hall. The wait is 1.0 km. The fourth edge is Payathai to Victory Monument. The wait is 1.0 km. The fifth edge is Democracy Monument to Chinatown, which the wait is 1.1 km. The sixth edge is Chitiada Palace to Payathai, which the wait is 1.2 km. The seventh edge is National Museum to Democracy Monument. The wait is 1.2 km. The eighth edge is Chinatown to Memorial Bridge, which the wait is 1.9 km. The last edge is Siam Square to Lumponi Park, which the wait is 2.0 km. These are the minimal spanning tree of Bangkok map. To identify the minimal spanning tree correct or not, we need to calculate the edges. The formula of find edges is number of vertex minus 1. So in this map we have 10 vertex, so minus 1, so we have 9 edges. Next we go to the calculation of Kruskal algorithm for Bangkok map. First we must list down the edges first. The first edge is Siam Square to Payathai. The wait is 0.5 km. The second edge is Democracy Monument to Chitiada Palace. The wait is 0.9 km. The third edge is Democracy Monument to National Assembly Hall. The wait is 1.0 km. The fourth edge is Payathai to Victory Monument, which the wait is 1.0 km. The fifth edge is Chinatown to Democracy Monument. The wait is 1.1 km. The sixth edge is Chitiada Palace to Payathai, which the wait is 1.2 km. The seventh edge is National Museum to Democracy Monument, which the wait is 1.2 km. The eighth edge is Chinatown to Memorial Bridge, which the wait is 1.9 km. The last edge, which the 9th edge, is Siam Square to Lumpini Park, which the wait is 2.0 km. So the total weight of edges is 10.8 km. Last but not least, we want to address the importance of minimum spanning tree. The only one thing we need to remember about minimal spanning tree is one thing only. A minimum spanning tree which the sum of the edges weights is as small as possible. With the help of examples and graphics, we presented and discussed minimal spanning tree in this video. We believe our explanation was concise and clear. That's all from us. Thank you for your time.